We also have rules for applying an exponent to a product, a quotient, and a power of something. We'll start with the power of a power rule. If we have some number and we raise it to the n power and then raise the result to the p power, then the result is to multiply the exponents. Why is that? Well, if we have x to the n to the p power, right, x to the n, that's n copies of x, all multiplied together. And now if we raise that to the p power, we're going to take p copies of that. And so we have n copies, and we repeat that p times. That means that we have n times p copies. In other words, we have x to the power n times p. So the reason that we multiply the exponents in this case is because we're actually taking p copies, each of which contains n copies, and that gives us multiplication. Okay, what if we're taking a power of the product of two numbers? So we have two numbers, x and y, and we're multiplying them and raising the result to the power n. Well, that's the same as raising the first number to the n power, raising the second number to the n power, and multiplying them together. We can, in some sense, distribute the exponent here. Well, why is that? So we have x times y to the n power. That's x times y times x times y times more copies of x times y. That's going to just be n copies. But using the associative and commutative rule, right, we see that we have n copies of x, and we also see that we have n copies of y. And so that means we have x to the n power multiplied by y to the n power. So that rule is just rearranging the factors in the parentheses. Similarly, if we're dividing two numbers and then raising the result to the n power, and here we just have a little note that the number we're dividing by cannot be 0. X over y to the n power, that means we're taking x over y multiplied by x over y multiplied by additional copies of x over y, enough that we have n copies of that. But when we multiply fractions, we multiply the numerators and multiply the denominators. So in our numerator, we'll have x times more copies of x, enough that we have n copies there. And in our denominator, we'll have y times additional copies of y, enough that we have n copies there. And so that is just x to the n power over y to the n power. So just looking at the definitions of the exponents, we get all of these exponent rules. And so far, they apply whenever the exponents are positive integers.